Okay, let's continue. Rational numbers in lowest form. So consider this example, 10 by 15. This is 2 times 5 by 2 times 3, which by cancellation law is 5 by 3. Sorry, 2 times 5 by 5 times, it's 5 times 2 by, 5 times 2 by 5 times 3. This is 2 by 3. Here 2 by 3 is the lowest form of expressing the rational number 10 by 15. So 10 by 15 is 5 times 2 by 5 times 3, which by cancellation law is 2 by 3. Here 2 by 3 is the lowest form of expressing the rational number 10 by 15. So we can ask vaguely, can we always simplify a rational number to its lowest form? So we begin to answer this question by first defining positive rationals. We'll consider lowest forms of positive rationals. So positive rationals, we say a rational number is positive if it's to the right of 0. Alternately, we say a rational number is positive if it can be written as m by n, where m and n are positive integers. These are precisely the rational numbers which are to the right of 0. We see that clearly by the definition of rational numbers. Okay, and so what is the common divisor? Common divisor of two integers. Let m and n be positive integers. Let d be a positive integer. We say d is a common divisor of mn if m equals dr and n equals ds for some positive integers. For two positive integers mn and a positive integer d, we say d is a common divisor of mn if both m and n are expressible as d times some positive integer. M is dr and n is ds for some positive integers r and s. Then we say d is a common divisor of m and n. Okay, this is what common divisors mean. Now we define. So here we have the question, can we always simplify a rational number to its lowest form? What is the lowest form of a rational number? So we define lowest form of a positive rational like so. Definition. So lowest form of a positive rational common divisor, positive rationals, common divisor, lowest form of a positive ration. Let A be a positive rational we say A is expressed in lowest form if we write A equals R by S, where R, S are positive integers and the only common divisor of R, S is 1. So consider a positive rational. We say it is expressed in lowest form if we can write the positive rational as R by S, where R, S are positive integers and the only common divisor of R and S is 1. So for example, here 10 by 15 can be expressed as 2 by 3, and 2 by 3 is such that the only common divisor of 2 and 3 is 1. So for example, the divisors of 2 are divisors of 2 are 1 and 2. The positive divisors, meaning, so we have defined common divisors, etc. Those notions for positive integers only. So divisors of 3 are 1, 3. The only common divisor of 2, 3 is 1. So hence we say that this 2 by 3 is in its lowest form, right? So here this 2 by 3 is in its lowest form. 2 by 3 is a rational number expressed in lowest form. Right, so this is what lowest form of a positive rational is. Observation. Lowest form of a positive rational. Let A be a positive rational. Then it has an expression. Let A be a positive rational, then it can be expressed in lowest form. Or to be clear, I'll write it. It has an expression as a fraction in lowest form. Right? So we can always find lowest forms of positive rationals. So here is the proof. So A is m by n, where m n are positive integers. We know 1 is a common divisor of mn, and any common divisor of m and any common divisor is less than or equal to m and less than or equal to n. So hence, among all common divisors, so there exists some common divisor, and any common divisor is less than or equal to m and less than or equal to n. Hence, among all common divisors of mn, there is a greatest common divisor. the greatest common divisor d. Now, so m can be written as d times r, n can be written as d times s for where r, s are positive integers. Now a equals m by n equals dr by ds equals r by s. Let hence that is a equals r by s. It now suffices to show. So we began with m by n and took the common divisor d, greatest common divisor d, and expressed m as d times r and n as d times s, and then we expressed a equals m by n equals r by s. It suffices to show a equals r by s is a fraction. So we basically cancelled greatest common divisor is a fraction in lowest form. After cancelling, that is, after cancelling greatest common divisor, do we get a rational in lowest form? Intuitively, it seems so. We have taken out all the greatest common divisor. Do we get a rational in lowest form? So it suffices to show a equals r by s in, that is, to show we need to show that 1 is the only common divisor of rs. Okay, we'll show that. Suppose there is an integer e greater than 1 which is a common, so there is a 1 is the only, we need to show 1 is the only common divisor. We are assuming there's a integer v which is greater than 1 which is a common divisor. Suppose there is some common divisor of rs which is greater than 1. Then r equals e times r dash, s equals e times s dash for positive integers, r dash and s dash. Now m equals dr equals der dash, n equals ds equals des dash. Hence de greater than d. So here we assume d is greater than 1. Hence we are saying that d is greater than d. Hence d is greater than d is a common divisor. Here we got the d greater than d is a common divisor. Is a common divisor of mn. This contradicts the fact that d is the greatest of all common divisors. Is the greatest common divisor of mn. Hence our initial assumption is false. Suppose there is an integer e greater than which is a common divisor of rs. Hence our initial assumption is false. That is, hence there is no integer. There is no integer e greater than 1 which is a common divisor of mn. sorry, it's a common divisor of RS as needed. Hence A equals R by S is an expression of A in the lowest form. So what we did was we expressed A as m by n, where m and n are positive integers. We defined the greatest of all common divisors of mn, which is d. We call that d, and we wrote m and n as d times some integers, positive integers r and s. Now m by n becomes r by s, and we are asking, is r by s a fraction in lowest form? So we have effectively cancelled the greatest common divisor of numerator and denominator and are asking, after cancelling the greatest common divisor, do we get a fraction in lowest form? Here we are proving it, that after cancelling the greatest common divisor, the fraction r by s which we get, in that fraction 1 is the only common divisor of r and s. To show that 1 is the only common divisor of r and s, we said, suppose there is an integer e greater than 1 which is a common divisor of r and s. Suppose there is a common divisor which is greater than 1. Then we can write r and s as some multiples of e. So r is e r dash and s is e s dash for positive integers s r dash and s dash. Then the original integers, positive integers m and n become m equals dr equals de times r dash, n equals ds equals de times s dash. Hence de greater than d. Since e is greater than 1, de will be greater than d here. And then hence de greater than d is a common divisor of mn. This contradicts the fact that d is the greatest common divisor of mn. We have found a common divisor de of mn which is greater than d. So this is a contradiction. Hence there is no integer e greater than 1. Hence our initial assumption. Suppose there is an integer e greater than 1 which is a common divisor of rs. That assumption is false. There is no integer e greater than 1 which is a common divisor of rs as needed. Hence A equals R by S is an expression of A in the lowest form. After cancelling the greatest common divisor from numerator and denominator, we get a fraction in lowest form. So for example, I like the questions in blue. The same question, what is the lowest form of 10 by 15? So the divisors of 10 are 1, 2, 5 and 10. The divisors of 15 are 1, 3, 5 and 15. So here the greatest of all the common divisors the common divisors are 1 and 5, right? The greatest of all the common divisors of 10, 15 is the greatest of common divisors is 5. Hence 10 by 15 equals 5 times 2 by 5 times 3 equals 2 by 3, and 2 by 3 is the lowest form of the rational 10 by 15, or we'll just write lowest form of 10 by 15, right? So that's all for this part. See you in the next part.